Ég ætla að tala aðeins Grænland og ég ákvað að hafa fyrirlesturinn á ensku. Aðallega af því að ég nenni ekki að þýða sérfræðiorðin og af því að þá kannski vonandi geta einhverjir erlendir aðilar horft líka á YouTube. So my name is Sólveig and I am a postdoctorate student. Postdoctor. How do you say fellow? Something. Well, I'm working on a project I've been working on a project in Greenland, which is part of a large project called Sticks and Stones. It's the Sticks and Stones project. Hang on. Where's it? There it is. And as the name suggests, the Sticks and Stones project was mainly focused on analyzing sticks or wood and stone from Norse Greenlandic archaeological excavations. And my part was stones. So today I'm mainly going to focus on the part of the assemblies that I looked at, the whole stone assemblies that I looked at, that turns to or revolves around the materials that were used for whetstones and grinding tools like sanders and smoothers and those kinds of tools. Hvernig slekk ég á þessum hérna sem sagt barinn fyrir nótunum mínum. Sorry. Okay. Yeah, so I've been spending the last few years working on the Sticks and Stone project, looking at raw material exploitation and distribution and their distribution from or at the eastern settlement of Greenland. So I looked at two stone assemblages from two excavation sites in the Íkavíkurfjörð. One was at the bishop's residence in Íkavíkur, in the inner end of the Íkavíkurfjörð, where we have a secondary 11th to 15th century midden. And then at Tatsipatakilak, we have a small farmstead in Vatnahverfi where we have a primary midden assemblage from a similar time period. So my focus today will be the raw materials of whetstones and possible grinding tools found in these two assemblages. And these are mainly mica schists or skiveberg in Icelandic and sedimentary rocks like sandstones and slate, which we call flöguberg in Icelandic. And just to say a few words about the area. We see that this is the eastern settlement, and this is the eastern settlement, and it goes from Kap Barvel all the way northwest to the glacial rim, and then we have the middle settlement here around the corner to the northwest. And these geological areas are completely different. Here we have mainly like a granitic batholith, and I will go into that a little bit later. And here we have a very old Archean crust, which is more over 3 billion years old. But we will talk about that more. later. So the two assemblages, if we basically look at the main or the basic composition, the two assemblages are only slightly different. At the Ikaliku, we have like 500 stone finds that were recorded, and together they weighed about like 40 kilograms, with many large finds and raw material fragments. But while the assemblage at Tatsibata is much more fragmented, we have 1,500 stone finds, but they only weighed around 13 kilograms. So there are more finds, but very, very more fragmented at Tatsibata. And just to show you just a quick comparison, we also have, I also put up here the goose assemblage, which is a farmstead from a similar period in the northern settlement. And here we can see that the how do you say, the materials are essentially the same. We have soapstone, we have Eriksfjord sandstone, and we have quartz minerals, and then we have a little bit of schist and a little bit of other material. At Tatsib, we have also soapstone making up the largest part of the materials. But while at Tatsib and Ikaliku in the eastern settlement, we have much more Eriksfjord sandstone, which isn't really, which isn't unusual because we're much closer to the source. But goose in the northern settlement still has possibly some Eriksfjord sandstone, but a little quartz material. But that isn't strange either, because at Tatsibata this is the midden, and here we have the discard, while here we have the discard, the quartz discard, while here we have the very few quartz finds. So this quartz difference is not really unusual. So we have, as I said, in the Ikaliku collection, we have about like 16% sandstone and 0.6% schist. And in the Ikaliku assemblage, we have about 20%, just over 20% sandstone and 0.6% schist in the collections. Just to show you very quickly, this is the eastern settlement, and this is the geology. And just to make matters simple and short, the Eriksfjord sandstone formations are the bright yellow areas right here around and close to our two sites. Tatsib is here and Ikaliku is here, and this is basically the Eriksfjord formation from where most of the or all of the Eriksfjord sandstone comes from. So it's very close at hand. But the schist, there's very little schist in the area. There might be some schist formations over here in the Samite zone, but then we only have, I only know for sure that there are microschist formations around the corner in the middle settlement over here, which we can see here. And here we have a large formations of microschist here. Here from Hovedal in the northwest, just all the way down here into Copper Mine Bay, all in this area. So there are a lot of microschist formations in this area here, but they don't seem, just to mention it straight away first, they don't seem to be finding their way into the eastern settlement, seemingly. But just quickly to look at the geology of the area, the substrata in the eastern settlement again is the Julian hopebatholite Bergklefur, which is largely a huge expanse of metamorphosed granite gneiss. Through the northern area, northern part where we have the two sites, have the Eriksfjord formations that are intertwined, basically sedimentary and basaltic layers. and these are formations that are riddled with later great dikes and intrusions of mafic rocks like dolerite and sienite. So there are different materials, but not very useful for whetstones and grinding stones besides the sandstone formations. This is me. Yeah, and we've already talked about the potential for schist, which is not very great. So just very quickly, if we basically just focus on the mica schists and the whetstone, the whetstone and the raw materials for grinding materials at Íkaliku, we have. If we just look at the mica schist and the sandstones, in Íkaliku, mica schist is like 1.6% of this part of the collection, which is basically only three pieces of raw material and no whetstones. While the Eriksfjord sandstone part is like 42%, and there we have raw materials and possibly some whetstones. In Tatsibata, we have mica schist, which is also about 1.6% of the collection, but these are only whetstones. And we have 55% of the collection is Eriksfjord sandstone, and these are only, and there in this collection we can only find whetstones and sand or sanders and smooth polishing stones, and possibly one or two larger raw material fragments for forming materials. And then possibly we have some Eriksfjord slate, which we will talk more about. If we look at the whole sandstone collection or assemblage, I split them into undiagnostic fragments, which are the blue areas. So we have a lot of undiagnostic fragments of sandstone in the Tatsibata collection. Polished striated surfaces are found in both the collections. Then we have whetstones, possible whetstones and polishing stones in the Tatsibata collection. We have a lot of flakes, a few parts that of very fine sandstone that may have been used as strikalites. We have a few water-worn monoports at Tatsibata, and then we have worked undiagnostic fragments and raw materials at Íkaliku. So the Eriksfjord sandstone is basically, as I said, a sedimentary rock formation of very varied colors. It's mainly red, dark red, wine red, bright red, and it got these characteristic pale patches. I don't know if you can see them. They're like very pale patches and circles. They are basically white. They don't know I don't think they know yet how they are formed. They think some sort of leaching, but this is one of the markers of the Eriksfjord sandstone formations. So these are basically very fine and fine-grained microcrystalline rocks and slate, and range from very fine to fine-grained, and all the way up to very coarse-grained sandstones. And here you can see some of the few larger finds that were in the Íkaliku collection. These look and are the size of whetstones, but they only have one or two of the sides that show signs of polishing or grinding. So they look and feel in the hand like whetstones, but they don't look the part. But yeah, the grain size of the finds suggests that these rocks were being used as polishers, as whetstones, as sanders, and possibly as grinders, some forms of grinding tools. At Íkaliku, we have an excess of raw materials all around the site. And we have a few large blocks of raw materials, but as I said, there are no true whetstones. And these are the roughly rectangular fragments. I don't quite know if these are just like broken roughouts. They're trying to make whetstones and they break or split, or if they're sort of just stones that people are grabbing and using and then just throwing away because there's so much material they don't really need to hold on to it or keep it. But we don't know. And if we look at the whole collection of or basically the whole collection of sandstones, not just the whetstones and the grinding stones, I sorted all the sandstone material into sort of 10 groups based on color and texture, ranging from microgranular, which is on this side, fine-grained, sort of to the middle and to the left, and then the coarser fragments are always to the left, finer and microgranular to the left, and coarser fragments you see on the right. So in the Ikaliku collection, it's not really, because there are so few fragments, it's not really representative, but there seems to be some sort of strange change. In the earliest phases, we have a lot of coarse material, like coarse sandstone fragments and raw materials and fines. But after the first phase, which is after maybe 1300, we have a lot more of very fine-grained sandstone. So we go from a lot of coarse to a lot of fine material with a little bit of coarse material. Why this is, I don't know. And as you can see, these are very few pieces, so it's not really, we can't really draw many conclusions from this. But as I said, colors range in this collection. These colors range from very pinkish or dark wine to grayish and reddish gray sandstone. And they're really easy to separate, because these are such distinct and pretty colors that it's easy to sort of sort into these 10 groups that I sort of constructed. But as we go through it, it seems that usually from the collection, the fines are made from the fines are roughly like 20 to 30% made from coarse grained sandstone, which would be good for sanders or some sort of grinding tools. But while the rest is very fine sandstone, which and slate, which would be sort of more similar to schist whetstones, fine and middling grained whetstones. So possibly whetstone materials and more coarser grinding and sanders in a lesser quantity. Just to look very quickly at the just the whetstones and the fragments with polished and striated surfaces. As you can see, these are few fragments, but there's like 30% coarse-grained material from these. These are 9 pieces with more than two or more polished surfaces, and there we have fine material, and then we have coarse-grained material. And the raw material is the same, but as you can see, this is only 3 pieces, so it's tentative. The Tatsiatakilek assemblage is much more fragmented, but it's much richer in fines, essentially. We have only 1 or 2 larger raw material fragments, while the largest part is sort of undiagnostic fragments and flakes that we don't really, that likely come from working the material and as debitage. We have fragments and a few whole cornstones, not cornstones, sorry, whetstones, And you can, as you can see here, these are sort of the best examples, and these are the larger fragments. And you can see here, these are rather coarse, and this very coarse-grained, more coarse-grained or medium to coarse-grained stones, whetstones. And then we have also the smaller fragments, which are much finer and more more similar to the regular, like the regular schist whetstones. And you can see these are very fragmented. These are small pieces, but they have two or more polished sides, and often they are square or rectangular in shape, but they are only small fragments as because the collection is so fragmentary. And these are definitely stones, whetstones, polishing stones, stones used as grinding tools. When we split the Tatsipata collection into these 10 groups that I made, that the picture at Tatsipata is much more, shall we say, beautiful. This here I have split the assemblage into phases, and you can see these are over 250 fragments of sandstone, and you can see that through the whole period from the beginning, from a beginning of the 11th century and up to the beginning of the 15th, there is seemingly very little change in the composition of the composition of the raw material, and the usage and doesn't seem to change, and it's likely that their sources didn't change. So it's a very different picture from the Ikaliku collection. So we have microcrystalline fragments and flakes here, used for polishing, used for strikolites, and possibly as cutting tools, because this is sort of like jasper-like material, which can be split and used and likely has at least a little bit sharp, somewhat sharp edges if we split them. And then we have the very fine and fine-grained whetstone, probably whetstone materials. And then we have coarse-grained grinding and sander material at the end. And again, this is also sort of like 20-30% grinding coarse material against 70-80% finer material. Just to look at the sort of, to pull out the fragments with polished and striated surfaces and the whetstones and the polishers. Again, we have the finest material, which is more common, and then we have a few more coarse-grained, like 30%, which is very similar to the Ikaliku, even though it's much more. So if we look at the phased morphology of the Erik Fjord sandstones, we see that these finds and fragments that suggest that they were being used as whetstones, as grinders, they are present through all of the phases. So they start right at the beginning to use the sandstone, and they keep on doing it for the whole time. If we look at the schist, the microschist, here we have at Ikaliku, we only have, as I said, we have one fragment, which is here, one large fragment of raw material, and then we have two more, which are much smaller and poorer in quality, but they are schist. But as I said, in Ikaliku, there is only raw material, and it's very likely. I didn't do a chemical analysis of it, but it's very similar to Eidsborg, the paler Eidsborg schist. At Tatsipata we have 12 microschist finds, and we have one grayish white whetstone, which is possibly the pale Eidsborg schist. We have 4 gray to dark gray coarse schist whetstones, which is possibly the darker Eidsborg schist. And then we have the very fine dark bluish purplish gray microschist, which is possibly from the Soknedal or Mostamarka area, which are 3 whetstone fragments. And you can see this very dark blue purplish whetstones here. These are the 3 fragments that are found made of schist in the Tatsibata collection. And then we have the fakers, which are very, very similar to the fine Mostamarka or the Soknedal schist that we saw before, but likely these are possibly slate, dark, very fine slate sedimentary rock possibly from the Eriksfjord formation. We don't know, at least I don't know, but they are very fine, and you can see that they have been used to polish, and this is a very, very smooth surface, even though it's rather jagged. And this one also has a smooth surface that sort of suggests that it's been used as some form of whetstone or polisher. So if we look at distribution, because the collections are so fragmented, we can't really tell much about the length of these whetstones or the grindstones that are present. So I sort of I chose fragments that have 2 or more surfaces that are smooth, and I measured the width and the thickness. And it's clear that there are sort of three main clusters, shall we say. We have the very small, the smaller rectangular or square whetstone finds that have a diameter or width and thickness less than 2 centimeters, which are very clustered, which show, and these are 50% of the 48 fragments that I measured, that or it was possible to measure with accuracy, which shows how basically how fragmented and small and well used this material in Tatsibata is in a sense. Then we have 20% of the larger, but also with a rectangular square section, and this is sort of one of the examples from Tatsibata, which we measured. But you can also see that if we measured this part of this whetstone, it would probably land in this category here. So we can't tell if this one was wider at the other end. So it could change if we could find more material. And then we have the other group, as we say, where we have fairly thin to thick, sort of more elongated rectangular square sections, cross section whetstones like this one from Norway, and this one made from the Eriksfjord sandstone. And here you can also see the sort of signature white leaching or white flecks of the Eriksfjord sandstone. Yeah. So these sort of split into 20% and 30% of the collection. If we look at the, I chose four of the Tatsibata schist fragments or schist whetstones to take samples for chemical analysis, and this analysis was done by ACT Labs in Canada in 2021 by Fusion, ICPOS, and mass spectrometry. And just because the university has acquired a PXRF machine, I sort of for fun did a little measurements of the same fragments myself. But very recently, Irene Baug, Dagfinn Skræ, and Tom Heldal and Austin Jansen, they've published an article where they discuss and present their recent chemical analysis they have done on the 4 largest whetstone mines in Norway. And here you can see that we have Mostamarka and Soknedal. This is Storenappe, which is basically the same rock, same geological formation, which crosses a large area, and these two areas are pretty similar in chemical, with a similar chemical signature. Then we have the Eidsborg area in Telemark, which has its signature, and then we have Hardanger, which is another geological formation in Hordaland. And here, just to recap, we have possible microschist formations in the Samite zone in Greenland, and then in the middle settlement. But I sort of, through looking at these whetstone materials, I didn't see any difference between the Norwegian materials I've been looking at in Iceland and the whetstones in Greenland. And it's sort of, I am pretty certain that these are most likely Norwegian microschist whetstones rather than Greenlandic whetstones. If we look at the, so Beck and her colleagues, they used 6 of the main elements and their ratios that are measured within the rocks to separate between these largest microschist mines. And they used silica, iron, magnesium, aluminium, titanium, and manganese. And here you can see the first one. Here they've plotted magnesium oxide against aluminum oxide, and you can see that the Soknedal and Mostamarka quarries, which are from the same geological formation, they are the yellow and the blue. And then we have the Telemark or Eidsborg quarry areas here, and then we have the Hardanger quarries, and these separate pretty well with these elements. If we look at the measurements that or chemical analyses that we did on these 4 fragments from Greenland, here the 1458 is the dark, very fine schist from Tatsibata, the very dark schist, very fine schist, and as I suspected, it lands very neatly, or at least the ACT lab measurements land very neatly in the middle, almost in the middle of the Mostamarka quarry area or quarry measurements. So basically, just to show you, the ACT lab measurements are these 4 here. And then I did, for fun, 4 measurements with the PXRF of the Soknedal or the Mostamarka fragment, and 2 of the possible Telemark fragment from possibly the pale Eidsborg schist fragment. And as you can see, the Soknedal, my measurements of the very fine schist sort of don't really behave. They cluster mostly nicely, and they land in the sort of ballpark area, but they land a little further afield than I'd hoped, shall we say. And this is the same for the 687, which is the white grayish white schist, which I think is the light Eidsborg type. The measurement lands a little, the ACT lab measurement lands a little bit outside. This isn't really sort of, we have to remember that the number of samples that they've analyzed from these mines, they're very few as yet, and at least one measurement lands very far to the lower end of the aluminum, and it's not unlikely that it will stretch as we do more samples. It would stretch in both directions. So it's not far off, but it's dubious, at least with these elements. But the 1172, which I suspect is the darker Eidsborg, lands within the Telemark quarry area. And then we have this fragment here is one of the gray slate possible Eriksfjord fragments, which lands outside and doesn't fit with any of the Norwegian quarries, which we like. If we look at the silica aluminum ratio against the iron and titanium ratio, we again see that the Soknedal and Mostamarka quarries isolate themselves very nicely from the Telemark and Hardanger quarries, but these 2 quarries are more difficult to isolate, shall we say. And if we look at the measurements of the Greenlandic samples, here again we see the 2 possible Eidsborg the 687 and 1172, they again land very close to the telemark quarries. And here, my measurements of 687, the gray possible iceberg fragment, they land within the telemark quarry ballpark. And here we see the fragment that I think is from the Soknadal or Mostamarka area is landing very nicely within this the measured amounts. But my measurements with the PXRF, they cluster nicely, but they land a little bit to the side, and they show us that they may not be. They could be from Soknadal, but while the ACT-Lab accurate measurement shows that this is likely, this could be a Mostamarka whetstone. And finally, the silica and the manganese. Here again, we have the Soknadal and Mostamarka quarries, and then we have the Telemark and Hardanger. Again, they separate fairly well, but the Telemark and Hardanger quarries are more closer together and maybe more difficult to isolate. And again, here, the possible two Eidsborg fragments land smack dab in the middle of the Telemark quarry area, while my measurements are a little bit off. Here, my measurements and the ACT-Lab measurements are much more similar, and they cluster nicely, but they are also still in the Mostamarka composition zone, shall we say. So most likely the dark blue, at least the dark blue 1458 fragment is likely from Mostamarka, and the others could be too. But of course we can't tell, they might be from Soknadal. And again, this shows us that this is the slate. It lands within the Hardanger quarries, and in the other one, it lands out the way outside, which shows it doesn't really fit very well with the schist microschist measurements. So if I split these very few microschist whetstone fragments between phases, it's clear that most of them, or 5 of them, are all in the lowest contexts in the oldest phase, while there's one fragment possibly from closer to 1200, 1300 phase, and then we have 2 gray schist fragments in the top. So these are very few fragments, and they are mostly in the earliest period, which could suggest that like in Iceland with soapstone, that soapstone was brought to Iceland as sort of a starter kit. It could be that schist was mainly a starter kit in Greenland and wasn't really, there at least wasn't a huge amount of it available in these, at least the Tatsibata in the Eastern settlement. And if we put these two together, we see that, as I said, schist is mainly here in the lowest and peters out as time goes by, but while the Eriksfjord sandstone material is there from the beginning to the beginning to the end. Finally, just to show you a slight comparison to Iceland, these are just very rough representations. Here you can see that in Iceland, in Stóraborg, Hjalmarvík, Aðalstræti, and Sveagott, which are sort of from these similar time periods, the main material is Norwegian micaschist. And with very few fragments or very few examples of whetstones that are made from Icelandic basalt, dolerite, and possibly sandstone, sandstone whetstones that may be reused grindstone materials. If a grindstone breaks, it's handy to make a whetstone or a grindstone or a polisher from that material to use it. While the Greenland material is at least the ones we have looked at are largely sandstone with very little schist. It will be interesting if I get to look at the Goose collection assemblage further to see whether the micaschist distribution will be the same whether the schist fragments will all cluster in the earliest phases and peter out, or if the picture will be different. And finally, just to show you a sort of estimated phase distribution of whetstones through these time periods in Iceland as well. Here you can see this is just a rough picture. This hopefully, once we start looking in more detail and sort of start collecting together information about whetstones between Icelandic sites, this might change. But here it's clear that the grayish-white possible iceberg schist possibly peters out a little bit towards the beginning of the 18th century, while the gray sort of gray mica schist is sort of always there and always present, and then we have a sort of an increase in dark gray, sort of more biotyped mica schist whetstones as time goes by, but always. And then we have here the Mostamarka Sóknadal possible areas in the yellow. There's a lot of material from the earliest phases, and then it sort of stays in the background, sort of in the later phases. And we always have Icelandic and sandstone, imported sandstone in very small quantities through the periods. So to conclude, sorry if you're falling asleep, so the Eiríksfjörð sandstone is the main material used for whetstones and grinding tools on both sides, and these collections are the complete opposite of Icelandic assemblages. These finds, at least the Tatsibata, are heavily used. They're small and they're fragmented and often split. So mica schist whetstones are rare, and they peter out very early and are likely from Eidsborg and Mostamarka. But this is a careful interpretation, and I'd like to just point out that we haven't done chemical analyses of any Greenland mica schist, and I haven't looked at any, so I don't even know what it looks like. So there's a lot more work that needs to be done. I mean, we never know. Some of the gray or dark gray mica schist from Greenland might land in exactly the same chemical sort of ranges, but my feeling as I look at these from whetstones from Iceland and Greenland, they are very, very similar, and because they're all most in the earliest phases, there is really no reason to think that they are anything other than imported Norwegian whetstones until further notice. So sandstone is sort of softer than metamorphic rock. It's more easily worked. You need less iron, and there's less strain on tools by using sandstone. And as we saw, schist in the Eastern settlement is in short supply. So sandstone this sandstone material may not have necessarily been better, but they were more suitable, easier to acquire, very close and cheap to use, and did the job. They got the job done, even though maybe it just would have been better, but if it works, why not use it? And there's very little, at least at Tatsibata, there's very little change of material use, raw material use of sandstone through the whole period. Thank you.
Takk fyrir þetta. Eru spurningar og svar?